All right, so this lesson is about differential equations, which is going to be in your test. It's going to be on a free response question. So you can get a lot of points out of this if you follow directions. Now, this first section is really mainly some review stuff about direct variation and inverse variation that I'm going to go over with you here pretty quickly. And then I'm going to make a second video on 7.2 is where the real work starts. So as this thing says at the top, this unit contains the most important application of calculus differential equations. A differential equation is an x and y. It is an equation that has an x and y in it and the derivative of y. So there's going to be a derivative in this. It's going to be a dy dx given to you, and you're going to have to find the original equations, and we'll talk about how to do that later. The solution to a differential equation is a function that satisfies the differential equation when the function and its derivative are substituted into the equation. And we'll go over that in more detail later. A solution to the differential equation could be a function, one singular solution, or a set of functions, which is a general solution. That'll be more of a plus c, and then this will be where we plug in numbers and find c. So examples of some differential equations is y double prime plus 2y prime, or the second derivative of y plus 2 times the first derivative of y equals 3y. Second derivative of f plus 2 times the first derivative of f equals 3 times f of x. And these two things are exactly the same as is this one. This is the second derivative of y with respect to x plus the first first derivative of y with respect to x equals 3y. So all three of these are the exact same equations. Before I start this number one, I'm going to go down here to this blue part here and talk about direct variation and inverse. So direct variation, which you should have had in Algebra 2 and maybe touched on in pre-cal a little bit, is y equals k is some constant, okay? It's the constant variation, direct variation. So when it's direct variation, you take k times the x value. And then down here below, the inverse variation is where you take k, the constant, divided by whatever it's inversely related to. So if I read up here, a particle moves along a straight line, its velocity v is inversely proportional to the square of the distance s. So again, v is going to be just regular old v, the velocity. And it's going to be inversely proportional, which means coming down here is k over x, but it's not to x, it's inversely proportional to the square of s. So it could have been this. This looks good, except you have a t squared in the bottom, and up here it says s. This one right here is going to be the solution to this. So this answer would be B. These are not velocity. This is the derivative of velocity, and this is derivative velocity with respect to t, but it's just regular old b up here. That's why we use b. Coming on down here to the next problem. Too far. A puppy gains weight, W, at a rate. Okay, now this says at a rate. So what that means is this is a derivative. So on this particular problem, we are going to have to say, use my finger. Sorry about this. So this is going to be dw dt, because, and it's dt because we're talking about t in terms of months, and it says at a rate. So this would be dw dt. And it says inversely proportional to t. So inversely proportional means your k goes on top and your t goes in the bottom. And that would be the solution right there. And this is not going to be on the AP test. This part right here is more of a review. That's why it's going to be short and quick. Okay, coming down here to the next one. The learning rate for skills of S is proportional to. Now, when it just says proportional, that means directly proportional. So this is going to be k times something, and it's going to be k times the difference between the max potential of learning M, and the skill already learned L. So this means its difference means subtract. So this one is going to be, and again, this says a learning rate. A learning rate for this S means it's a derivative of S because rates are derivatives. So we would say ds, and it would be with respect to time. Dt down here, and it says proportional to, so that's going to be k times something. And what it says it's proportional to is the difference, so we're going to have to do a subtraction problem on this one, and it's the difference between M and L. So this would be M minus L, and that would be the equation for the relationship of all this stuff. Coming down here to number 4. Number 4 says an IV drip administers medication to a patient's bloodstream at a rate of 3 cubic centimeters per hour. So that means that's the rate starting off. Okay, so and at the same time the patient's organs remove. So I hope you know remove is minus. Remove the medication from the patient's bloodstream at a rate proportional. So it's going to be K times something, and it's going to be to the volume of the medication in the bloodstream. Which of the following is that relationship? Okay, so again, I hope we see that this is at a rate of 3 cubic centimeters. So what that means is we got a dV dt, which they've all got that. And we're starting with 3 going in, and we're subtracting out because we're removing K times B. So that is going to be this one. Okay. Going on to the last problem in this section. It says a chemical is diluted out of a tank by pumping pure water into the tank and pumping the existing solution out of it at a volume at the time T equals 20 plus 2K. The amount Z of the chemical in the tank decreases at a rate. So again, we're decreasing Z at a rate, so that's why all these are dZ dt at a rate proportional to Z. So that means proportional to Z means we're going to take K times Z, and at the same time that K is inversely proportional to the volume of the solution in the tank. Well, if you look up here, the solution in the tank is 20 plus 2T, which means this is the part that's going to have to be in the bottom. Okay, so all this is coming out, right? So we need to make this a negative value because we're talking about diluting it, making it less. So when I look at all these, this is going to be the answer because it's directly proportional to Z, inversely proportional to 20 plus 2T. That's why it's written like this in the formula. And it's negative because we are diluting, taking out, making less the amount of solution in the tank. So I hope that worked all right. Just so you guys know, I'm having symptoms now. I went to go get tested today, and as of right now, I'm going to be out of school until the 12th. So sorry for that. I haven't been feeling very good the last couple of days. I went and got tested